Hey everyone, so continuing from the previous video, I would actually like to talk a little bit more about some of the minor stuff about stationary points and also relate it back to parallel lines in particular that's actually specific to stationary points. So we know that stationary points, there are only three types, but for this video I'm just going to concentrate on the two types as for now, the minimum point and the maximum point. If we actually remember the previous example, we have y equals to x cubed minus x squared plus 1. And we found out that there are two maximum points and two stationary points, one at x equals to 2/3 and another at x equals to 0. And if you just scratch the graph, you notice something. X equals to 0 is equals to 1, so this is my maximum point. So I'm going to start drawing the graph here. So make it nice. And then at 2/3, and this is the graph of y equals to x cubed minus x squared plus 1. A very striking feature is that you notice that the maximum point at x equals to 0, y equals to 1 is not the maximum value of the graph. The minimum point at x equals to 2/3 and y equals to something is also not the minimum point of the graph either. Because you notice that there are this point that are more negative than this minimum point, and there are these points that are way more positive than the maximum point. So this brings me to the actual definition of stationary points, is that they are the local minimum, and local maximum. And local in the sense that it's only minimum of, like, for instance, from somewhere to here. So let's say around from the previous turning point to this turning point, and local maximum from this turning point here to, let's say, the nearest tearing point, or from negative infinity. So just because there is a minimum point or a maximum point does not mean that it's actually the minimum value of the graph nor the maximum value of the graph. Although in some cases it is, right? For example, the x squared graph, the minimum point is at 0, 0, and is indeed the minimum value. If it's the minus x squared graph, the maximum value is indeed 0, 0. So in some cases, yes, it is the maximum and it's a minimum. But most of the time when you're doing your application questions, usually the minimum and maximum values are indeed the graph's minimum and maximum values. Another topic I like to actually relate you to is the idea of parallel lines. All right, we know that a horizontal line for a stationary point, it means that its derivative is therefore 0, right? So when dy by dx equals to 0, it means that it's a stationary point. So when questions say that, let's say the tangent at the point let's say x equals to a is parallel to the x-axis, so the horizontal axis, immediately you know that the gradient of the tangent equals to 0, and is hence a stationary point. The next one, which I'm going to talk about, is what happens if the tangent at x equals to, let's say, b is parallel to the y-axis. This is mainly for the H2 math students, but for those who hate math students, you can also kind of take a look. If it's parallel to the y-axis, let's actually think about it this way. If your gradient is vertical, it means it's very, very, very positive, right? It's almost towards infinity, right? Towards positive infinity or negative infinity, right? For one, you don't know, right? So basically, you know that it's infinity, right? Modulus infinity. And what this means is that the gradient is actually undefined. Undefined in the sense that it is the denominator of the gradient equals to 0. The reason is that you cannot divide by 0, right? And if you divide by a very small number, it tends towards infinity. If you divide by 0, if you think about the layman's term, although it's kind of incorrect, that is a very, 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 very big value, almost towards infinity. And therefore, for a gradient to be undefined, the denominator of the gradient of the function is 0. So for instance, if I have, let's say, dy dx equals to, maybe 1 over x minus 4. So at x minus 4, we know that the denominator is therefore 0. The gradient is actually going to be parallel to the y-axis. Alright, because the denominator is equal to 0. And yeah, that's about that. And of course, if we talk about perpendicular to the y-axis, if the gradient is perpendicular to the y-axis is equal to 0, because it means that the gradient is actually parallel to the x-axis. Alright. Likewise, if we have gradient is perpendicular to the x-axis, then we know that the gradient is undefined, which means that the denominator of gradient of dy dx equals to 0, because gradient is parallel to the y-axis. So yes, this kind of sums up the whole stationary point. Obviously, I haven't shown you any specific examples yet, but I'll upload some of these examples in the near future.